Hey again. I want to talk about accumulation under a curve, which is the area under a curve, and kind of move in a direction here. But this is an example where we can find the area under a curve, which is basically more along a combination of straight lines. So this problem here, it says it takes 50 minutes for Joe to notice that his cola bottling machine has sprung a leak. So if you kind of look at the graph, you can see that from 0 to 50, he has like this slow decline, which is the leak. Joe is able to stop the leak in 10 minutes. Well, that is when he figures it out at 50 and at 60. So more or less what you're seeing here is when the leak first starts, he's losing 10 gallons per minute. Then as there's less and less fluid in there, it's going to have less pressure to cause less drainage out of it. So at 25 minutes, it looks like he's losing about 9 gallons per minute. So as we move along here, because of how much is in there and the pressure and what that's causing the flow to be, even though he's sprung a leak, he's not losing as much every minute as it go along here. But it's a steady decline. This is a straight line, so it has a consistent slope. But then when he finds the leak after 50 minutes, he can kind of work on it and plug it up. So you see that he starts losing less and less very rapidly. So at 50 minutes, he's losing about 8 gallons per minute. But then at 55 minutes, he's losing around 4 gallons. So this is where he's patching it up and slowing it down dramatically. But what we're saying here is when it starts off, he's losing 10 gallons per minute. At the 5-minute mark, if he was to measure it, he's losing a little bit less. The 10-minute mark, he's losing around 9.5 gallons per minute. So what we're trying to do is figure out how much he lost all the way around, because for these first 5 minutes, he's losing about 10 gallons a minute. So you would almost assume that in these first 5 minutes, he's going to lose about 50 gallons. Now, because there's a steady decrease here, or decline, it's not going to be quite that. So let's see how we would handle this problem, because the question is, how much cola does Jose lose in the bottling disaster? Okay. Oh, excuse me, Joe. So down here what I did is I took the actual graph and I separated it into figures that we know. So what we're trying to do is figure out the total area, because we're talking about what happened at 1 minute, what happened at 2 minutes, what happened at 3 minutes. So we're really trying to add up little pieces under here for each position. So we're trying to figure out the total amount of cola he lost, which would be under the curve. So I divided it into 2 triangles we see here. And we know that the area of a triangle is 1/2 base times height. And we also have this rectangle, which is length times width. I know it looks like a square, but if you look across the bottom, this is 50. And this here is 8. So even though it looks like a square on the graph, it's not really a 1-to-1 ratio there. So if I take these, what I've done is I've calculated the blue triangle has an area of 50. That is a height of 2 and a base of 50. The orange, which doesn't really look orange, triangle has a base of 10. So keep in mind that these are different scales, and a height of 8. And then the yellow, which looks like a square but is really a rectangle, has a width of 50, well, a width of 50 and a length of 8, or interchangeable there. But I've got the 3 areas of the 3 figures, and I would total them all up to get 50 plus 40 plus 400 is 490 gallons. So this should allow us to figure out the total area under this figure. Now this is very nice because these were straight lines, so that allows us to break it into nice geometric figures like triangles, squares, rectangles, possibly trapezoids, or something that we are familiar with. But everything comes together very nice here. Alright, we'll move on to something next.